Hello friends, myself Pramod Phatak, Assistant Professor in Department of Chemistry of late Pushpa Devi Patil Arts and Science College, Risur. Here we are continuously seeing your unit first, and from unit first the part A, that is the covalent bonding. In last some lectures, or exactly last three lectures, you have seen the lot of covalent bonding, and it means LCAO method, linear combination of atomic orbitals, then bonding molecular orbitals, anti-bonding molecular orbitals, and in last lecture you have seen the bond order concepts. Okay, so what is the bond order? The bond order is the bonding minus anti-bonding molecular orbitals divided by 2, you get the bond order. You have lastly seen. Now today we will discuss the different examples of bond order. So today we are going to see the molecular orbital structure of various molecules. Here are some points which we have to know. The first one is the finding which atomic orbitals are involved in linear combination. Then second, finding which molecular orbitals are formed. Then third, finding how the electrons are distributed in various molecular orbitals. Then fourth one, the drawing the molecular orbital energy level diagram. Then calculating the bond order. Then sixth, symbolically representing the molecular orbital structure. And the last one, discussion on important properties of the molecules on the basis of molecular orbital structure. So here we are going to see some examples and their molecular orbital structure or molecular orbital diagram. So first one is your hydrogen molecule. You have lastly seen this example when you calculate the bond order. Okay, hydrogen molecules means H2. H2 means two hydrogen atoms. Okay, so here it represents the one hydrogen atom, that is 1s, this atomic orbital, and his electronic configuration is 1s1. And the second hydrogen molecule also the same electronic configuration, 1s1. Both are having one electron in their shell or outermost shell, only one electron. When that two electrons from one hydrogen molecule and from another hydrogen molecule, they gets combined. Okay, this is the bonding molecular orbitals, and there is no extra electron which fills the antibonding molecular orbital. So here is the zero. So you calculated the bond order. Okay. So this is the revision for you. You calculate the bond order of this molecule. Okay. Now we are going to see the next example, that is the helium molecule. Also, you have also seen this example of helium. Here is the electronic configuration of helium. One helium atom is the 1s2. Okay. Every electron or every helium atom has a two molecules in his outermost shell. So here is the two helium molecules. So first one is this helium. Here is representation of this helium, and another helium atom is here. So both helium atoms are having two electrons each. So this bonding orbitals having two electrons, also their anti-bonding molecular orbitals is fulfilled with two electrons, means sigma orbital is the bonding molecular orbital and sigma star is the anti-bonding molecular orbital. So here what is the representation of this one? Sigma 1s2 and sigma star is 1s2. Okay, you have calculated the bond order. Bond order means bonding minus anti-bonding divided by 2. So bonding molecular orbitals are 2 and anti-bonding molecular orbitals are 2. So 2 minus 2 get is equal to 0 divided by 2 means 0. So bond order is 0. That's why this molecule is not formed, or sometimes it formed but not a stable molecule. Okay, and He2 molecule is diamagnetic. All electrons are paired. So here is the concept of your paramagnetic, diamagnetic, and if both the electrons are paired, then this is the diamagnetic. Okay. Next one is the nitrogen molecule. So N2. What is the electronic configuration of nitrogen? 1s2, 2s2, 2p3. So from this, the only 2s and 2p electrons are uh, having a combination, means this 1s2 means is these two electrons are isolated, or they doesn't take part in your molecular formation. So only these 2s2 and 2p3 means 3 and 2, 5 electrons are take part in the bonding. Okay, when this nitrogen molecule is combines with another, so only these 5 electrons take parts in bonding. There are 14 electrons in N2. Okay, the ground electronic configuration of N2 molecular is therefore sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then 2px, pi 2px2, pi 2py2, sigma 2pz2, and bond order is the 10 minus 4 is equal to 3. So in this, the both the nitrogen atoms are having triple bond. It indicates three bond order represents the nitrogen molecule is having a triple bond. Here is the representation. This 2s atom, sorry, 2s uh, uh, and this 2p is from one nitrogen atom, and this 2s and this 2p from another nitrogen. So both are having the 5 electrons means 10 electrons. So from this getting a bonding molecular orbital, this, and from this the anti-bonding molecular, and from these two p orbitals, this pi 2p and 2p, both these bonding molecular orbitals are filled, and this anti-bonding molecular orbitals, that is pi star and sigma star, are empty. So here is the bonding molecular orbitals: 2 plus 2 plus 2 plus 2. It gets 8 minus this 2. So you get this 6 divided by 2 is equal to 3. So here is the bond order is 3. Okay. So N2 is the diamagnetic in nature. Now next example is the oxygen molecule, O2. So oxygen is having electronic configuration 1s2, 2s2, 2p4. Likewise, same from the nitrogen atom, only 2s and 2p takes part in, or involves in the bonding, and this 1s 2 means these two electrons are isolated. So here is the same, both this 2s and 2s from both the oxygen atoms, and this 2p and this 2p are from the both the oxygen atoms. So these take parts in bonding and anti-bonding. So from these 4 electrons, these bonding and anti bonding sigma are fulfilled, and from this p orbital, this sigma, this pi star and this sigma star, so these bonding molecular orbitals are filled, and this is the unpaired electrons in pi star. So here is the bond order of this is 2. So how we calculated the bond order? Bonding minus anti-bonding. So these two are bonding plus these two and these 4, 8. 8 minus these 4. Okay, these two electrons and these two electrons. 8 minus 4 means 4 divided by 2 is equal to 2. This represents the oxygen or O2 having a oxygen double bond oxygen. This bond order represents the double bond. Okay, here is now we are going to see the both different atoms, that is carbon monoxide CO. In carbon monoxide, the bonding orbitals resides more on the oxygen atom and the anti-bonding orbitals resides more on the carbon atom. Here is the homo-lumo concept, both the this oxygen 2s and 2p. Here is the sigma pi, pi sigma, and here is the LUMO of this carbon. So here is the bonding of this CO. Two molecules means oxygen 2s having sigma and pi, and this p orbital of oxygen, here is the 6 electrons and here is the these 4 electrons. Okay, so likewise the same another example of HF, hydrogen fluoride. Hydrogen atom of air is here and this is the fluorine atom. Hydrogen having only one electron in his 1s and fluorine having 1s, 2s and 2p, means 1s2, 2s2, 2p5. So this is the combination of HF molecules having 1s2, 2s2, sigma sp, these two, and from this antibonding orbital is empty. So bond order is this sigma is having 2 and this is the empty, so 2 minus 0 divided by 2 is equal to 1. So HF is having a bond order 1. Likewise the same NO. Okay, so what is the difference between VP theory and MO theory? This is the comparison. Atomic orbitals are involved in bond formation and identified in retain. Means both the theories are given the exact molecule structures and their properties and their spectra, but the difference is this is giving the exact bonding molecular orbital and anti-bonding molecular orbital, but this is having means valence bond theory as having some limitations, so it can't represent everything, and this MO theory means molecular orbital theory is here is the their comparison. Okay, here is your unit first is over. Thank you.